Got it. It said got it. Welcome everyone to 2022. Hopefully, hopefully it's going to be an awesome year. It's funny. It was really, really cold today, and I woke up this morning to an email from a SPAT member saying, "Can I come and get some oysters?" And uh, they're under the ice. There's no boat in the water, and it's really cold. So if you want to go get your oysters, you can go get them. You just have to be really hardy. I'm not hardy at all. I don't particularly like winter, but the good news is oysters really do like cold winter. Last year, we saw kind of slightly higher mortality than we've seen in previous years in the last couple of years. We had good growth, we had a good year, but there was definitely mortality of big oysters, and I would say that was because of dermo pressure, which is an oyster disease that is around in our waters for sure, and it manifests itself a lot more after a warm winter. So for all that humans, or maybe myself, I don't know how many SPAT members I talked to this week that were like, well, I'm in Key West, and I'm in Nicaragua, and I'm in all these glorious places, and I'm just sitting in front of my wood stove watching the flame go by at night. But it's good news for oysters. It's actually better than a warm winter. So what's going on with this session is we're going to do things a little differently than we've done for the last 21 years. This is our 22nd year of giving these kind of workshops or whatnot. And as I was saying before, the seasonality of what we do is very evident when you a nice little oyster picture, whoever that is. What these lectures or workshops have always done is follow the progression of what we need and what we're doing in our shellfish hatchery. So algae is always the first thing on the agenda when you're starting up the system, because it is the base of our food chain. And again, I'll remind everybody that the PowerPoint lecture and Josh's lecture are recorded. They're on our website. Go and check them out anytime. Most of the information all of the information that we gave last year is there, and so it doesn't go away. So we're trying to do something a little different to add to our archives of a more open forum about algae in general. We do have some guests that will be talking. So we have Steve Schott, who is our resident marine botanist, and he is going to give us an update on kelp production that has really ramped up in the Peconics in the very recently, and in a lot of places. I think you're going to hear a lot of buzz about sugar kelp. So he's going to talk about that. He also happens to be a wetlands specialist, so eelgrass, and we don't want to take up everybody's time. This could go on. Our workshops on algae used to go 2.5 hours. I don't know if I know Tom doesn't want to be around for 2.5 hours. No. So but what I would say, and Josh Perry is here, he's going to give us an update on his algae systems, which are really, I would say, some of the most state-of-the-art at large production, and the bioreactors are certainly something that not everybody has, and actually probably don't operate as well as he has done with Cornell. So he's going to talk about that. And then we have the SPAT guys with Charles Peck, Dr. Charles Peck to you, Charlie Peck and Frank Kelly, who run our SPAT Algae Room. So we should all be in attendance. And I think what I'm going to do is I'm going to open it up with Steve Schott to give his spiel on. Now, here's the ground rules. It's good to have folks muted so there's not a lot of background chatter in case your kids are beating on the dog, or you're cooking popcorn, or you're having a barbecue in your living room or whatever. But if you have questions, unmute yourself and ask the question. We're going to do it as an open forum of questions instead of saving them for the end, so that if Steve wants to move on after he does his spiel, he certainly can. You can ask the questions. Then we'll go to Josh, and then we'll go to the SPAT guys, and I'll be in between, and Darcy's there to help us out. So if Steve is there somewhere, I see Steve Schott.
I'm here.
There you are. Wow. Take it away. Oh, look at your ear. You've got a Stephen Colbert ear going on.
Oh, I know. Isn't it wonderful?
Cool. Yeah, that's awesome.
Well, I had to put my background up though.
Yeah, I love it.
So
go ahead.
As Kim mentioned, my name's Steve Schott. I am marine botany and habitat restoration specialist for Cornell Cooperative Extension. I've been doing this for 22 years in like another 2 weeks. So I've been here for a while. My background shows kelp and eelgrass, the two things that I work or have worked primarily with, but in recent years, we've gotten more into living shorelines or more natural shorelines, and we'll be doing a lot more of those projects in the future as well. But yesterday we had as part of the Cornell Cooperative Extension Ag Forums, we had a joint aquaculture session. We had Greg Rivara hosted the shellfish aquaculture session in the morning, and I hosted the second of its kind on Long Island Seaweed Aquaculture Forum in the afternoon. And they both were well attended, well over 50 people in each session. And we had a lot of really good feedback from everybody on our presenters, and talking about, that where aquaculture on Long Island is going. So can I share screen?
Yes.
Okay.
I think Darcy's going to set you up with that.
Let me make sure. Yeah, you should be able to. You're a co-host, so.
All right. Can people see the picture?
Yeah, beautiful.
So this is kelp, also known as sugar kelp. We have two species of kelp on Long Island. We have sugar kelp, and then we have what's called horsetail kelp. The sugar kelp is the one that's most commercially exploited. Long Island is the southern geographic range of sugar kelp on the East Coast, and it goes all the way up into the Canadian Maritimes. Cold water species. So it has two phases of its life cycle. So this is the one that we're used to seeing, and this is around during the wintertime. So probably early fall, right into probably June is where most cases in our warmer waters, it starts to die back, and we won't see it through the summer. Although if you go out offshore into like 30, 35 feet of water, it'll be around all year, but it doesn't look real good. It gets pretty ratty. Not real tolerant of water temperatures over 70 degrees. And with global climate change, that's becoming a problem. So Montauk Point, right underneath the lighthouse, if you go at a nice low tide, there'll be sugar kelp growing, in like 2-3 feet of water at low tide. That's probably as far south as kelp goes. Maybe on some of the shallow reefs off of Shinnecock. I haven't dove those personally, but and I haven't heard any reports. But doesn't really grow in our bays. Most of that's mostly because, number one, they get real hot in the summertime, so it'll kill off the other stage of this life cycle is microscopic. It's a male and a female plant, and they're just these little hair-like filaments that attach to rocks. They don't like the temperatures over 70 either, and our bays definitely get over 70. So really it's confined to the east end of the Peconic estuaries, Orient Point, Montauk Point areas, and then Long Island Sound. So it comes in different. So this is a strap-like form. You notice there's no wavy edges or anything special. This is in off of Fisher's Island on the South Shore, and it gets blasted by waves. So the blades are real thick, almost like belts, and they are not fragile at all because they do get whipped around by the waves during the winter. But if you get into areas where it's a little calmer, this one's off of Orient, about 25 feet of water in a kind of protected area. The blades, you get a little more frilly and wavy margins on them. You'll get this, the center section here that's, different looking, and they're a little less less robust in being able to deal with getting beaten up. And then this is just another one. So this is a little later in the season. So this would probably be June-ish. One of the things that we worry about for kelp aquaculture is these farmers are growing kelp starting in December. They put their kelp, the kelp seed strings out on lines, and it grows through the winter, but they need to harvest before the water gets warm enough where things like these little lacuna snails really start getting active, or other species of algae or even other animals start to grow on the kelp. Lacuna snails are cold water tolerant. They love kelp, and if you get enough of them and you leave your kelp out there, it'll look like someone shot your kelp with a shotgun. So you definitely, farmers definitely want to get their kelp out before the lacuna start to become active for the season. Let's see. So this is some of the kelp that we've grown in the past on lines. So there's an actual 1/2-inch nylon line. And what we do is you set kelp spores in a hatchery or a nursery onto a 1 millimeter nylon string, and they will grow eventually as you take them out. We'll grow them for about 6 weeks in the hatchery setting. They get to about 1 to 2 millimeters long. Then we'll take that string, it's on a spool of about 200 feet, and you basically wrap it around your 1/2-inch line out in the field. Now, these were 25-foot lines. I'm currently working on projects where growers throughout Long Island, we have 14 of them total, are working with 100-foot lines. So each line has, each site has at least 2 100-foot lines, and we're doing different experimental treatments on those to just kind of get an idea now that this is becoming an industry that looks like it's going to be moving forward with the newly passed kelp bill. We're just trying to start to do the development and help growers out ahead of time. So actually, I'm getting ahead of myself. But when you harvest the kelp, this is what it would look like coming off. So most of those are going to be about 8 feet long. Kelp can grow up to about 15 feet long. I have seen that in New England growing in the wild, and it's really pretty impressive. One thing to say about our kelp is, if you've seen pictures of kelp, like on National Geographic and things, it's all floating in the water column. That's West Coast kelp, totally different. Those are growing in 200 feet of water, one of the largest organisms on the planet. They have air bladders, like little buoys that they grow along their lengths to keep them suspended upright in the water column. Our kelp is slightly buoyant, but close to neutral. So really it just kind of flops back and forth along the bottom. So it's not one of the things where if you hear kelp forest, we call them kelp beds because ours lay down like a person would. So kelp forest really doesn't apply to the East Coast. And this is a section of one of the 100-foot lines we did in 2020 in Great South Bay. You can imagine these get quite heavy. So I think that's about a 10-foot section. That was probably 50 pounds, 60 pounds of kelp on that line. The one bad thing with kelp is it's 90% water. So when you dry it down, you're only getting 10% of the weight. But in most cases, most applications for food, it's used fresh. This was at the Hort Lab in Riverhead, where they were taking this kelp, and the previous picture where it was hanging up in the greenhouse drying, they actually did fertilizer trials for several species. And actually, I believe this year they're working on a fertilizer trial on turf grasses. There's evidence from an old experiment that using kelp-based fertilizers on turf grasses can impart some drought resistance to the turf grasses. So if that's the case with the amount of turf grass that's grown on Long Island and the amount of fertilizer used to grow it, if we potentially could have a local industry where we're kind of cycling it, we're growing the kelp for the fertilizer, putting it on the land, we could really reduce the runoff and also benefit our turf grass industry too. So this is a blade of kelp. There's two sections here. These are this margin here is this lighter color. Now this dark section is how we tell the kelp is reproductive. It actually becomes raised and very, very dark. Underwater, we'll either take a flashlight with us, the divers, when we're harvesting, and shine it behind. If you can't see the light through it, it's pretty much ripe and ready to bring back to the lab for spore release. A lot of times I could even just hold it up to towards the water surface, and the sunlight is enough to tell. And you can kind of get an idea that there's raised sections. It doesn't do it in any kind of uniform instance. It can sometimes only develop near the top, sometimes it'll develop near the bottom, or mix throughout. We like to try to find sections that are nice and solid like this, because we chop them into, I'm not advancing. Hold on, let me pull up that. So that middle section gets cut out, and we cut into these little pieces, and those little pieces are dropped into chilled seawater. And here it's hard to tell, it's getting a little cloudy. Oop, wrong one. And I didn't really have this set up as a PowerPoint because Kim said that not to bother with that, but now you can really see. So these are the spores that are being released out of that material. So this is what we want to have, and we look for the spore density. So if any of you guys have ever helped with your shellfish spawning, it's the same process. So I would take some of this water, put it under a microscope, do some counts with a hemocytometer, and we're looking for anywhere between 5,000 and 10,000 spores per milliliter is our target base for us to inoculate our seed string for the kelp on spools.
Hey, Steve.
Yep.
I just see a big gray box.
Yeah, a blue screen.
Oh, really? Can you see anything now?
No,
No.
there's something behind it, but there's a big gray box in front of it.
Okay, hold on.
It's a nice gray box, though. Now it's
All right, hold on.
Make
I
a nice
didn't mean
soup.
to throw you off with the PowerPoint, but
I should have done it that way,
There it is.
but
Yeah, now we got
so this is the cut up pieces. Let's see, it's not going to let me advance it. I don't know why. So I don't know why it's giving me problems, but anyhow. So let me just see if I can't get one more picture to come up, and I'll show you what our nursery looks like, and I think that'll give you the picture of what we're dealing with before we get to what you saw on the lines. Usually I'm
well, and again,
better prepared.
No worries, Steve. The thing is, we would love for you to do a formal PowerPoint at any time if you want to do that.
And that's, yeah, we talked about that. I just wanted to give you a taste of this. And I actually do have a formal PowerPoint. I just don't have one on my home computer where I am now. So this is what a typical kelp nursery would look like, the setups. These are the spools. Each spool has about 200 to 220 feet of 1 millimeter nylon line. These are set, we have ours set up in water baths. So this is a fresh water bath that's set to 50 degrees on a chiller. We have LED lights that we use, grow lights. Very important for the kelp that you control the light, because we want to trick the kelp. It's a winter species, so it's used to short days and lower light intensities. If you blast it with long days and bright light, it'll actually bleach the kelp out and it'll kill it, especially the young versions. So we're able to dim our lights and control it during the process. So we start out with relatively low lights. The little guys would be growing underneath their parents and would be a little shaded. And then as we, once we get into say 3 or 4 weeks after these have been, the spores have been set on these, and you can start to see they'll turn brown, you jack the lights up a little bit and they really start to take off after that. And we water change these weekly, but the big thing is maintain the short days and keep the water temperature around 50 degrees. And basically you trick it into thinking it's wintertime and they'll grow. But and then once these are ready, this year we started putting handing spools out to the growers to put on their lines the second week in December. We would like to try to get that earlier and earlier. Our problem is with climate change and things getting warmer, the kelp, because the water temperatures stay warmer in the fall later, the kelp is becoming reproductive later in the year. So it used to be that we could start our spool production in mid-October. Now we're lucky if we can do it before the first week in November. And of course, we're locked in with 5 to 6 weeks of growing in the hatchery before we can put them out. So, but that's the process right now. Right now, there's one commercial permit in New York State, and I'll stop sharing. There's one commercial permit in New York State, and that is in Brookhaven Town waters. And you cannot grow kelp right now in the Suffolk County Aquaculture Lease Program. That was the law that the governor just signed about a month and a half, 2 months ago, the kelp bill that people heard about. Really all that is conservation law in New York State regarding aquaculture never had seaweed included in the aquaculture laws. It was only shellfish. So basically all they did was took the conservation law and said growing shellfish, and they added "and seaweed" to allow it. And being that Suffolk County, the shellfish aquaculture and the Peconics was deeded over to Suffolk County by the state of New York, they have to change the law before they can change the legal contracts. So until that's all taken care of, kelp will not be allowed to be grown on leases in the Peconics and Gardner's Bay. So the South Shore Estuary is different. Brookhaven controls their bottoms. Islip Town controls their bottoms. Right now, Brookhaven is allowing one person. They've gone through the federal and the state permitting process, as well as the town. Islip is working on that now.
Steve, how long is that going to be then to add?
For Peconics?
Yes.
I wouldn't bet on it until 2023. They have to, so DEC actually has to go through and change the laws and then they have to go in and change their contract wording with the county. And anytime you add lawyers to a mix, I'm optimistic it'll happen before that, or people would be able to put their applications in 2020, late 2022, to be ready to go by fall of 2023. But I don't want to get people's hopes up. But it could possibly, the earliest I would expect it would be fall 2023 would be that people would be able to put lines out on their grounds.
One other question with that. Is there a way, or is it being looked at? You had a drying area you showed. Would it be smart to, as a cooperative group, try and establish a drying area and what we're going to be doing with the seaweed, so that once we have it, we know what to do with it right away and how to work it? Can we do that preemptive?
You could. There are groups that are talking about that. I'm working with a group called Lazy Point Farms, and they're a branch of the Moore Family Charitable Foundation. And I've been working for them for 2 years now, and they're the ones that are funding the research that we've been working on the last 2 seasons, but they're also branching out and looking into how do we process, where do we process, and how do we, now we know how to grow it, how do we sell it? So the problem we have is in New York, we are at least 5 years behind Connecticut, and we're about 35 years behind New Hampshire and Maine in seaweed aquaculture marketing. So, and right now, New York City's demand is met by Connecticut. So a lot of it, and there is some processing that has to go on. One of the talks
Did
we
he
had yesterday.
freeze, or is he thinking?
Who, me? Can you hear me?
Oh, who?
I guess he froze,
No, he's not frozen.
or did I freeze?
I think you did. Steve's
Oh.
not.
Okay. So we had one of the talks we had yesterday was by Dr. Michael Ciamarella from Sea Grant, and he is their seafood food handling expert. And so DEC only oversees the growing aspect at harvest, and what gets done after that is all ags and market. And New York is trying to figure that out. So that's the next step as well. There is some processing that usually is done. Most fresh kelp is brought in and blanched. So basically that's just dipping in boiling water. That's to kind of just kill off any bacteria that may be on the blades. Lazy Point Farms did test kelp that was grown throughout Long Island last year, and they're going to do it this year for microbes, and they found absolutely nothing pathogen wise. So no E. coli or anything like that. So it's not like shellfish where they're filter feeders and they're ingesting these things and kind of accumulating them. The kelp doesn't take in bacteria. It would, if anything, the bacteria would just be on the surface. So that's why the blanching method is a way of processing. So you guys, as growers, you would be looking for a place that you could process. Connecticut, if you want to look into it, Brandtec it's called. It was developed with the help of Connecticut Sea Grant, Greenwave, and Yukon. And they are a kelp processing facility. And they do everything, flash freezing, freeze drying, vacuum sealing, all of that. And they're doing that kind of research as well. So that's something that we're looking into doing and developing on Long Island.
Awesome. Any other questions for Steve?
There were a couple of questions in the chat.
I had
Well, if anyone,
one
there you
quick
go.
question.
Sure.
You mentioned the newly passed Kelp bill. So what exactly does that cover?
That only covers addition of kelp aquaculture to the conservation law. And really it directly affects the Peconics primarily. And that's because, so there's no aquaculture being done in Long Island Sound proper. There is aquaculture being done in some of the Long Island Sound bayments along the North Shore, but those are usually under the jurisdiction of towns. But in the Peconic Bay and Gardner's Bay are under the jurisdiction of the state of New York. To develop the Suffolk County Aquaculture Lease Program, they actually signed over their management rights to Suffolk County. And the problem in that is the language in that in the law that handed over that or deeded that that management to Suffolk County, it does not mention seaweed. It only says that people can grow shellfish on their leased properties.
Oh, okay.
So this authorized DEC to change their law and then allows for the changing of the law that handed over. So there's 2 laws that have to have language changed. One is the state DEC has to include in their laws that seaweed can be grown as an aquaculture product. And then The second law is the agreement between New York State and Suffolk County deeding the management of the Peconic and Gardner's Bay bottoms for aquaculture.
And the newly passed law then is the first, covers the first?
Nope. The newly passed law authorizes DEC to change the conservation laws. So this is why things take so long. So the bureaucracy was, we had to pass a law to enable DEC to make that change. DEC now has to change the law, and then they have to change basically the contract that the state of New York had with Suffolk County. So, and there's lawyers in each step. So yes, that's what makes it interesting and hard to predict how long this is going to take.
Okay, thank you.
Steve, Tom Mormon asked, are there any odors from this use for fertilizer with the sugar kelp?
Typically, no. So when it really depends on, so if it's harvest before you start getting fouling organisms on it, like you get things like tunicates, bryozoans, or if there's a lot of snail loading on them, anytime you get animals that are going to be in there, those will smell. Come by our shell pile at Cedar Beach and you'll see what marine animals will smell like. Kelp and seaweeds in general, as long as they're not left, so the kelp is dried. So and honestly, so as a botanist and a marine botanist, I have pressed specimens that are 20 plus years old that I've done. As long as they're kept dry, they don't decompose. In general, that's how botanical specimens are maintained, just by drying them, be they land plants or otherwise. We don't need chemicals or anything, and they never smell. If you were to leave them wet, that's another story. They're going to smell a little bit. So like the situation they had in Heckscher State Park this summer with all of that red seaweed that was washing up and really foul. One of the things is red seaweeds give off different chemicals and they are very foul. But it was left to be wet and decompose. And also there was an oxygen issue. So as it's decomposing, it's sucking the oxygen out of the water. So now you're not only decomposing, but you're anaerobically decomposing. So that produces hydrogen sulfide gases, which smell like rotten eggs and everything. So, but kelp is usually, you can hang it up on clotheslines and dry it, or put it in drying ovens, commercial drying ovens like they use for hops. And once it's dry, it really doesn't have much of a smell.
Excellent. What was the company? Ed Thompson asked, what was the company you mentioned in Connecticut?
Greenwave is a co-op. Brent Smith is the famous leader of that over there, but originally they were developed in coordination with University of Connecticut. They do have a website, and most of the kelp growers seaweed growers in Connecticut are affiliated in some way. They are, I believe, interested, once New York's kelp industry gets up and running, of possibly expanding into New York as a co-op.
Okay. Ed just corrected himself and said he meant to ask about the research and processing company.
Brandtec is the name of the facility. It's BRANTEC. And I'm not sure who runs that, if that's a greenwave, if that's an NGO, but it was developed with in cooperation with Yukon Greenwave and Connecticut Sea Grant.
Excellent. And the last question I see, is it being looked at for animal feed? I understand it cuts down on the methane gas released by animals.
We're not looking at it specifically on Long Island right now. We don't have, well, although a lot of people since the pandemic started have decided to take on chickens as livestock, and they have been fed dried seaweeds in the past. It is used throughout the world to feed livestock. Seaweed is. If you can look up online in Norwegian countries, the Scandinavian countries, they will actually at low tide drive their cattle and goats and sheep out onto the flats at low tide and allow them to graze on seaweed. And I used to have a picture, it's on my other computer, and in a presentation showing a cow up to its belly in seawater with waves lapping and sticking its head underwater, grabbing seaweed and eating it. But it can be used for that. It really soil amendments, human food, animal food, and then pharmaceutical and cosmetic uses. Kelp especially produces a chemical called alginic acid, or alginate, and that's typically found in products that you want water and oil not to separate. So it's a kind of an emulsifier. You'll see it a lot in your salad oil and vinegar salad dressings. So, you know, it can be used, and most of the chemical need, that raw chemical is satisfied by production in the Asian countries. So if we could potentially, you know, ramp up our production in the United States on both coasts with seaweed aquaculture, we could start keeping some of these base products being produced in-house and hopefully cut prices.
Awesome.
Right. Sorry. So can I just ask a couple of questions there?
Go for
Steve,
it.
what are the there's obviously a lot of potential in terms of applications, but what are the current markets and applications for the East Coast product?
Well, right now, food is still a big one, typically dried. So a lot of dried kelp is sold throughout the country that comes out of Maine, New Hampshire. Connecticut is starting to, although Connecticut has right now, I think Connecticut's got 6 to 8 farms. Most of their fresh produce production can go right to New York City. And that's because they are working with Greenwave, and I think they help them with that marketing aspect. And it's such a big cultural center where there's a lot of cultures in New York City that are not averse to eating things like seaweed. Most Americans we weren't raised on that. Sean Barrett yesterday, he's the co-founder of Montauk Seaweed Supply Company. They've been buying kelp from farmers from Connecticut so far, and they've been making seaweed fertilizer out in Montauk. And he in his presentation yesterday, he said we're more of a burger nation than a seafood, even across the board. But a lot of other cultures, we're one of the few countries in the world that has such large amount of coastline, and we really don't take advantage of our marine resources the way others do. In Europe, they eat a lot of seaweed, and then of course in Asia they eat a lot of seaweed, and Americans are kind of behind the times on that. So once demand goes up, food would be a good one. And again, seaweed is very stable once it's dried, and if it's maintained being dried. So that makes it attractive as far as some of the markets.
Steve, I have a question. What is the seaweed that is in the miso soup that we get so often?
That is usually a different species of kelp. It's usually kombu. Just like the seaweed salads that you get are green, they're really not. It's a brown seaweed that's like kelp. And the thing is, if you put a brown seaweed like kelp in hot water, the brown pigment in it is water soluble, whereas the chlorophyll that makes plants green is not. So the brown washes out and leaves behind the green. So yeah, that's in miso soup is usually either kombu or wakimi. Those are 2 Asian kelps typically.
Thank you.
Awesome. Well
Okay.
done.
Yeah, I don't want to take up any more time, but Kim can, if you have any other questions, Kim can get you my actually I'll type it in the chat my email address, and people can send me any questions they have.
And
Sure.
we might
Can
talk.
can I just ask a quick one there?
Sure.
When are you seeing sugar kelp reproductive?
Sugar kelp starts to show development of the reproductive tissue, which is called sorus, typically around early September, late August, early September, but it's usually not ripe and ready to go around here until mid to late October.
Okay, thanks, Steve.
You're welcome.
I think there's enough interest that we should probably do a formal presentation one of these days, and maybe we'll poll the group to see if they're interested in having a full Steve Schott presentation. So we'll look forward to that.
Steve,
Good
you're
one.
gonna put your correct email, right?
Yeah, I just saw that.
Okay, cool. Thank
Good,
you
good,
so
good.
much. That was wonderful.
All right, guys, and I'm
thank
gonna
you
go
so-
gonna
thanks
go
so
make my
much.
wife a nice steak right now. So.
Yeah, good. We are a burger nation after all. So don't put any kelp on top of it. Yeah.
All right, everyone. Have a good
Thanks so
night.
much,
Thanks for
Steve.
letting me speak.
That
Take
was
care.
awesome. I like the hairstyle that's going on in the
Yeah, I
background.
know. Right now, it looks like I'm Darth Vader.
Yeah.
All right, take care.
Yeah. Hey,
Have fun, Josh.
is Frank and Charles there? I see Tom Mormon.
I see Charles joined a while ago. I'm not sure about Frank.
Yes, we're here. Frank is here
Oh,
with
you're
me.
here. Good. Why don't you
Hold
guys,
on.
since
Hold
you're in
on.
since you're in the
Hold-
hatchery there and Josh
Hold on.
is lounging
Can you
at
hear-
home. Yeah, that's
can you-
good. We're seeing your algae tubes.
Okay, can you hear us?
Yep.
Okay, we have a little problem here.
Okay.
We've never been here at night and we ran into someone here.
Oh, really?
Good evening. My name is Count Algae. Do you know why they call me Count Algae? Because I love to count algae. Oh, sorry about that.
Okay.
We're here.
There you are. And you do have to count a lot of algae which maybe you can egg SPAT members onto coming and helping you count algae. There's the boys in the SPAT Algae Shack. So why don't you give us a spiel there?
Okay, well, welcome everybody. This is Frank. This is me. And we're here in the algae room, which we started 3 years ago, and it gets better with each year. So here's what happens. I'm going to take you on a little tour.
We see your face. Great. What happens?
Hold on. Whoa.
Uh-oh.
Hold on.
I know. We should have had Rory with a.
Okay, here we go.
Oh, that's good though. That's good.
Okay, so we start out with an algae culture in a flask like this. And this whole process reminds us very much of going to school. So this would kind of be kindergarten in school. We introduce a culture. We grow 5 different kinds of algae. And we start in these flasks, and they stay in these flasks for about 2 weeks. And then they graduate to something bigger. We call these carboys. These all contain 10 liters of salt water with added nutrition to it. And you can see we've got several different colors here. Again, we grow 5 different kinds of algae. They're of different sizes and of different nutritional values. And this is going to be used by our broodstock oysters that we're working on at this point. So we say the carboys are kind of like elementary school or maybe junior high, and then they graduate to cylinders. And these are some of the cylinders we have growing at this point. Frank is mastering the use of a plastic bag, which has more volume. We're trying to increase our production by about 15% this year. And what we're doing currently is feeding oyster broodstock. This means that we take about 2 dozen oysters, and we started 2 weeks ago, took them out of the creek, we warmed them up, put them in a tank. They kind of start feeding on their own, and then we feed them 24/7 for about 6 to 8 weeks. Here's a big container of algae that we're feeding them. And if we're fortunate, after 6 to 8 weeks, we'll put them in a basin, heat them up to about 80 degrees. And if we've conditioned them well, then they'll spawn. And these 24 oysters may spawn as many as 20 million larvae. So when they're first spawned, they're very small, they're very tiny. So the best food for them is this brown algae called pavlova. They grow very quickly. And when they reach a size of around 150 microns, which we can measure, then they graduate to this lovely soup that we've made called tetrasolamus. And then they set on the eggshells or the crushed oysters that you've heard about before, and they continue to grow in our conicals, and we have to keep feeding them until the creeks get warm enough, somewhere between April 15th and May 1st, to create their own algae, and then they get transferred to the algae that's grown in the creek. So that's a very condensed version of what we do. It gets very, very busy just before the algae starts growing in the creek, because these 10 or 15 million larvae get very hungry, and it's all we can do to keep up with them. So it's a very intense, labor-intensive process, but it's a lot of fun. We're getting better, a little better at it each year. Just a couple of footnotes. You often hear about bad algae, but there's a lot of good applications for algae. One of the things I just acquired was a new pair of running shoes, and it's made of completely sustainable materials. One of the materials is sort of a dried algae that has been made from algae that actually was a algae bloom in seawater somewhere. So it's now utilized there. So there's many, many applications that are very positive for algae. So this gives you a little version of it. This is the high school version of the algae. When they're in the cylinders, it's about 200 liters. And we'll go through 2 of these cylinders a week, just feeding these broodstock oysters, getting them ready to spawn. So that's my story, and I'm sticking with it.
Are you sure that algae wasn't on your feet to begin with?
Well,
No.
you never know.
You never know. And I guess you can do some product placement. What was the brand name?
No, I'm not. If someone's interested, contact me. It's the brand name is just Google sustainably manufactured running shoes. There's about 5 different brands now,
Wow.
which is recent, because up until about 2 years ago, there were no sustainably made running shoes. It's a big, a lot of very severe petroleum products were used in running shoes, and now there's a big movement towards more of these sustainably made ones. And the first pair I got was from Adidas, which was made from ocean plastic, but only about 25%. So I used to call those garbage shoes. Now these are made from corn and algae, and I call these my corn runners.
There you go. Tom wanted to know if anyone had degrees, a PhD. It says BS. We're all full of BS. So, that's our degree, is BS for sure. And well, and also the plug is, Frank and Charles have been they are in charge of the algae room. But if people are interested in getting involved, let us know, because he was talking about count, what was it? Count algula, whatever it was. You have to, in order to quantify your algae, you have to count it, and you have to pretty much do it manually. So that's something that people can get involved in. And there's a lot of cleaning and maintenance and whatnot, and learning the protocol. If anyone's interested, that is SPAT's algae room. And it's pretty cool, right, guys?
It is. Does anybody have any questions about the mechanics of the operation? What we're doing as far as air supply, or how we clean these tubes? Nope.
Well, again, we can, there is the last year's I think has the protocol, but also because it would get pretty involved to talk about everything that you guys do. I think if you want to do an independent workshop on actual algae, single cell algae culture in the SPAT Shack, we could do that.
Okay.
And
Kim, is there any algae that, the good algae that can eat the bad algae?
well, algae doesn't eat, algae is what's called an autotroph. So it's a self-feeder. It's like a plant. And by the way, because somebody asked the question, what about algae and kelp? And keep in mind that all algae and kelp and just about everything that seems to be a plant in the ocean is actually in its own kingdom, the kingdom protist. So the only marine plant we have in all of New York is eelgrass. That's the only true plant. Everything else is a protist, and they don't eat per se. They photosynthesize. They need CO2. They give off oxygen. They're very plant-like. So now, the interesting thing, and I think here's a convoluted way of answering your question, Tom. When brown tide came into Peconics in the 80s, it outcompeted the good algae. In other words, it was blooming to such proportions that it kept the good algae from growing. And so in a way, it was eating it. In a way, it was eating it out of it was eating its nutrients to keep it from growing, you see, or eating its requirements to keep it from growing. So it could outcompete the good algae and grow really well. So in a way, that could also happen in reverse, theoretically. You could have a really good, healthy, hardy, useful algae growing within a range that was beneficial to it and not a harmful algae. So that's a scenario where a good algae could outcompete a bad algae, which would be nice once in a while to get something like that happening. And maybe it does all the time. I mean, in a way, maybe that's what keeps things going, is that the good algae do a good job of keeping other harmful algae at bay. And you wouldn't maybe notice that until you get a bad algae and it makes all the news. You see what I'm saying? It could be happening as a matter of course. It all has to do with ranges and requirements, light, nutrient, temperature. These kind of things are what's going to determine which algae are doing well at what time or what requirements. So that's an interesting take on that. There was a question about, sounds like Omicron. There was a question about the algae species that we grow. None of them are indigenous per se. They're all aquaculture grade algae. And there is a diatom, Chaetoceros, that grows locally that we grow. I don't know if we grow the same one. I'm going to turn this over. Does anyone have anything else to say to Charles? And other than I appreciate you going down to the Marine Center in 6-degree weather and showing it live, because it's more fun than showing it. It's virtual, but it's more lively virtual. So I appreciate.
Thanks, guys. Thanks.
Coming out. So we're gonna go over to Josh if he's still there. You still there, Josh?
Still here. Hi, guys.
Hey, there he is. Awesome. And the show is yours. Take us.
Amazing. Awesome. Charlie, Frank, your guys' stuff looks absolutely incredible. So, if this is something that interests anybody, we highly recommend you guys getting in with Frank and Charlie. And, one, they definitely probably need the help. And two, it's really cool. And as future oyster aquaculturalists, you should be obsessed with algae just because it's what drives everything. It grows your babies up. It's the babies that you're going to be getting, is what they're eating when they're in their larval stage and everything. So I'm going to get more into this kind of, the algae we grow for aquaculture and expand in probably in a lot more detail on what Charlie and Frank are doing. We're going to move fast through a couple things just because a lot of it is definitely repetitive from last year, but there's some cool new pictures and videos and stuff I want to show everybody. So we're going to try screen sharing to see how this goes. All right, let's see if we can do this. All right, can everybody see that?
Yes.
And that amazing. All right, cool. All right. So those who were there last year or saw last year's presentation, this is going to look really familiar, except everything's going to be, just kind of, going down a little bit. So when we talk about microalgae and aquaculture, and we talk about algae in general, it encompasses such just a wide variety of different organisms. The beautiful thing out of all the thousands and thousands and thousands of different microalgae species that are out there, shellfish aquaculture in particular obviously has a huge economic impact. And since that, there's been obviously a lot of research done into it. So it takes a lot of the guesswork out for us, which algae species, would work at this point in time. Granted, in the past, a lot of trial and error, and unfortunately in our line of work, stuff has to die in order for us to figure out what's going on. But in general, there is an industry standard set of microscopic algae species that are used in shellfish aquaculture. So as Charlie and Frank beautifully explained before, you have your baby food and your adult food. And generally there are two types of algae that we grow in a hatchery that are classified either as flagellates, which are algae cells that are able to kind of move and swim around, or diatoms, which are encased in a glass shell. And believe it or not, that glass shell is made out of silica, and even further so, that shell is actually opal. And if you look at the chemical compound of opal, it is another form of silica. So the question is, and my joke is, if you get a bunch of diatoms together and crush them down, could you eventually, make opal? I don't know, possibly. So you have, if you can see my cursor, you have your baby foods, which are generally smaller swimming algae. And, algae is going to move for two different things. One, it's going to move to get away from predators. And two, and also it's how it eats. So algae gets all their food and all the beautiful nutrition by swimming around, and the water passes through the cell membrane, and they get all their, delicious nutrition to do their thing. And unlike plants that grow big and tall, how we judge algae strains and algae just in a hatchery is by how dark or how dense an algae strain is. So the darker the algae, the algae culture is, the higher quality shellfish food it is. I like to compare it to beer because it's a pretty easy, comparison. So I don't know, this is kind of looking like a Bud Light. So this culture might not, isn't necessarily the highest quality shellfish food, whereas this culture down here is as dark as a Guinness. So that to us is telling us is really, really nice, healthy, great shellfish food. Just because, it's a whole volume thing. So if you're getting water with algae in it, you want to make sure there's actually enough algae in there that your animals are going to find in your tank. And in the beginning stages of shellfish aquaculture, having a very specific types of algae is of the utmost importance, because you have good algae that are beneficial for shellfish growth and other algae strains that aren't healthy for shellfish growth. I know there was a question earlier too, just before I move on, going off, that these algae strains aren't native. And honestly, if any of these algae strains took over in our water, it would be a blessing because it's delicious. So, and as we go on, there's a lot of different ways that you got to keep everything clean. And if you kind of void from the protocol, if anything gets into your algae culture, it's going to have a field day. One, either a strain of algae that's unintentional, so it's going to outcompete the algae strain you're trying to grow for nutrients and outgrow it, or you're going to introduce a predator that could either eat your algae strain, and then if you feed that to your shellfish larvae, which are microscopic, you could potentially kill your shellfish larvae. So in aquaculture, we want to grow as much algae as possible, as quick as possible. It doesn't have to be 100% perfect, but it has to be good enough that if we feed it to microscopic shellfish larvae, we won't have to worry about stuff killing it. So as mentioned before, they are like a plant without being a plant. So you need a light source, you need your miracle grow, CO2 for photosynthetic, for photosynthesis, the algae you need, protocol and equipment. So just kind of, I'm gonna exit that out. Just kind of basic requirements for algae. Doesn't like it too hot, too cold. And the strains that we grow, they don't like it too hot, too cold. So kind of Goldilocks 3 bags kind of situation. And I'm also realizing too, I didn't properly introduce myself to everybody who don't know me. So for those who don't know me, my name is Josh. I'm the Shellfish Hatchery Manager for the production hatchery on campus. So I run the commercial size facility, on there. I've been growing shellfish for around 14 years and been growing algae for around 7 now. So I used to run an algae lab in a private shellfish hatchery before Cornell. And that was a great learning lab to be a part of. So moving on. So, when we talk about algae, everything has to be clean. And the reason why that is the organisms and, the algae strains we're growing are very much so alive. They're really small. And to kind of put it into perspective, we measure microns in algae cells in microns. So 1 micron is 1/1000th of a millimeter. And the smallest strain of algae that we grow, which is your isos and PABs, are 4 microns. So really small and have a potential to get, contaminated by something that could be undesirable. So there's generally, I like to compare this to kind of putting a fish into a fish tank that you just kind of put in. So when you put algae into a new container or a new vessel, whatever you're trying to grow it in, there's a little bit of a lag from, and we'll get to the different size containers as Charlie and Frank explained before earlier, but you kind of have a shocking period where the algae is just kind of like, whoa, man, what's going on here? This is new. And then as it gets more used to the container that you have it in, you're going to have a period of growth that just kind of explosive growth. You'll come in and your culture is, will look so much darker than the next day. And then after a certain point, it'll kind of stop. And then eventually, unfortunately, unlike everything, it eventually will die. But generally, we are really interested in the aquaculture world in this little bubble right here. Just because algae grows, it's new, it's fresh, it's exciting, it's nutritionally, delicious. But as the culture gets older, it loses some of its nutritional value, unfortunately. So if you can keep your algae cultures in this constant, beautiful state of logarithmic growth or just growth, you're looking at a really good oyster at the end of it. And in terms of growing shellfish in general, diet is a lot. And to put it in perspective, last year, we got some oysters that were, that we grew for the SPAT program, and we're seeing growth rates of 7 millimeters in 1 month in the hatchery. And that was just being fed a really high quality diet of different algae strains. So food is of the utmost importance. We couldn't do any of this without the algae available to us. So generally in the history of shellfish aquaculture, there's been 2 methods of, growing algae for shellfish aquaculture purpose. You have the super old school method, which is the Wells Glancy method, which pretty much you dump container of fertilizer into a body of water, and then you put your shellfish in that, nutrified water, let a natural algae bloom happen, and then your animals will eat that algae. Could you imagine now if somebody tried to do that today? If you found, if you live in a waterfront property and you found your neighbor was dumping just bags and bags of fertilizer to grow algae for their oysters, people would throw kind of a little bit of a fit. So it's not really ideal because 1, obviously because of the pollution aspect of it, and 2, the algae that may bloom up may not be, beneficial for your shellfish. So Kim mentioned before harmful algae blooms, and they are part of an algae family called dinoflagellates, and evolutionarily they're incredible. And it's a shame that they are as toxic as they are because they would make amazing shellfish food, but you kill your competitors and then and inhibit your competitors and kill your predators. So it's a great survival strategy. So, for a hatchery method, we want to be able to control what we want to grow, just because up until the point where the animals reach an outside system, we need to be able to control what's coming in so we can maximize our production. So this is where this method comes in. This is where Charlie and Frank's method kind of originates from. So this is called the Milford method, and I'm realizing during when going from a Windows computer to a Mac computer, my presentation got a little messed up, but that's okay. But pretty much you start out with a little small desired strain of the algae you want to grow, and you put into a bigger container. And then, once that bloom is up, you put that algae into a bigger container, And, if my apartment was a glass container that was allowed sunlight through and didn't allow any contamination to occur, I could fill my entire apartment up with algae. That's kind of the nice thing about it. As long as it can grow anywhere as long as it has the requirements to do so. So you start off with your smaller cultures, which are stock cultures up here. and then you move on to, you know, potentially larger culture. And you do it all under flame. And I have a video actually from, I don't know if anybody's on TikTok, but from my TikTok, of me doing some stock culture transfers in our hatchery. So let's see if I can get this to play. And if I can get it to play, and all transfers is what we do to keep our algae going. So if we just took the algae that was in this flask, we put it into a new container, that algae's gone. We won't be able to use it again. So we want to ensure that we have a library of algae culture is, you know, kind of on reserve. So if our bigger containers go down, we have something to replace that bigger container. So algae, you know, you take a small amount of population, you put it into some clean water, or we could even talk about, you know, compare it to maybe grafting a plant. You take your branch, you put it in the new soil, new media, it's going to grow. You're going to do the same thing with algae. So you take a little bit of the old population, put it into a flask that has sterilized seawater with fertilizer in it, and then you let it bloom up. And everything is all done under fire to prevent contamination from occurring. So here's a fun
Time to give our algae garden some love and care. Step 1, a clean counter is a happy counter. Step 2, grab your older algae cultures and a clean flask. Step 3, add fire and pop the top. The flame prevents contamination. Step 4, pour old algae into new flask. Ray flame and seal the top. Fresh and clean. Step 5, back on the shelf they go. The new flasks are new stock cultures, the older. Flasks move on to eventually become food for millions of baby shellfish. Follow along to learn more.
All right. So, so yes, that's pretty much how transfer is done. And moving on, you know, so we want to make sure that we have enough algae to fill our bigger containers, because a small amount of algae in those small flasks, just the algae will take too long to come up. And like I said before, we're in the business of producing as much algae as possible, as quick as possible, and have it be, you know, relatively sterile, so we can feed it to our animals. And by God, do they eat a lot? Oh my goodness. So of course, you know, cleaning is a key. So after everything is all done, you have to clean everything out. So here is Mike, who runs our research lab at Cornell, and here he is, you know, using some pretty nasty stuff, unfortunately, to clean some of the glassware. But you got to ensure that nothing's living, you know, because you're growing the base of the food chain here. So if there's anything that's in there, like I said before, they're gonna have a field day. We have an autoclave, which heats up our flasks and carboys under heat and pressure to ensure that we, you know, are killing everything within the water, that we don't filter out. And our larger hatchery, again, going back, here's our smaller stock cultures, and we don't do the intermediate flask method. It's kind of, we don't need to do it. We get pretty good success and, you know, moving our stock cultures to our carboys. And here's kind of the amazing thing, is these carboys are just food storage containers. So as long as you have a way to seal the container up, you know, keep it, you know, free from anything from entering in, put a light source behind it, have the algae, and, you know, apply the proper amount of, you know, milk or grow, you can get algae cultures to grow up in pretty much, you know, everything. And, you know, we label everything because, as you can see, most of the algae we grow are all browns. There's only one green. And the color is all for, you know, photosynthesis. So you have certain pigments that allow for light to be ingested pretty much, or certain pigments that, you know, get, you know, different levels of light and different colors of light away. So, you know, so in terms of, we're going to kind of blast through this. So you have batch culture, which refers to just one, you know, one culture, you drain all the way down, fill it back up with new clean water, new algae, set and reset. So that's kind of what the Caldwell system is. And the tubes that Algae and Frank have, they're called K tubes or Caldwells. It's just pretty much a clear fiberglass tube. You fill your tube up all the way with water. You have your algae in a carboy. You dump your algae carboy into the tube, cover it up, and then let it bloom up. And then after it blooms up and gets nice and dark, you harvest the entire thing out over time, clean it, and then reset. So, you know, it's very cheap, which is kind of nice. You can get really simple with growing algae, or as we saw before in a little bit, you can get also really complicated. So, you know, clear fiberglass tubes, you put a light source behind it, add some clean water in there, throw your algae in there, and if all goes well, you'll have some delicious shellfish food. You know, so it's pretty easy, it takes up a low workspace, relatively cheap. If they break, low technology, so very easy to repair. And you get some pretty good algae cultures out of it, but you're limited to, you know, to the amount you can harvest out based on the size tubes you have. They can leak. A lot of it's all manual labor. There's a lot of cleaning associated with this system. You have continuous culture, which allows for a continuous harvest of algae, and we have 2 systems on campus that allow us to do that. You have in the most common called a CCAP system. So the CCAP system utilizes a series of clear plastic bags. You have these cages which form the bag as it fills up full of water. You get your bags, they're sealed in both ends for sterility. You take a little poker, you poke a hole in it, you fill it up like a balloon until it feels like the Pillsbury Doughboy. Once it feels like the Pillsbury Doughboy, you can start to add water. And as you can see up here, so this is how water is delivered, and I have another picture showing the guts. So water pretty much will come down these tubes, come down this tube right here. Once this bag is blown up, it will pop into the top of the bag and eventually drip water in. Algae is introduced into the bag through these little belly buttons right here from the carboy. So the beautiful thing is everything is all tube to tube, no outside contamination risk at all, which is great for us. And the algae does really well too. So here's kind of the guts. So the water will come in, get heavily filtered to this one head tank, and we'll go to this little mini head tank, which controls the entire system. We sterilize this water by it going through a pasteurizer. So this heats it up to 196 degrees Fahrenheit. It'll pass through this heat exchanger, cool down to room temperature, and then fill the bags up. So as you can see with all the pretty coloration we have going on here, the algae does really well. And it's a really, really nice, stable system for us. So, since we have a commercial size hatchery, if we can cut down on any labor time as much as possible, we're going to do so. These systems take a little bit to bloom up, but in terms of its robustness and just how long the algae culture stay, it's absolutely incredible. We'll put it this way, is there was one row of bags that I only had to inoculate once in January, and it lasted up to a very acceptable density all the way through November with no crashes. And that's pretty amazing. Whereas with the K tubes, unfortunately, you may or may not see crashes every 4 to 6 weeks, depending on your system. So eventually the bags will fill up to the top and become these beautiful pillars of algae you see. So once the algae reaches to this point, we will attach a little drain line. So as the water drips in, the algae will constantly drain out. And we'll go down these gutters. And then from the gutters, we'll go to the barrels. And then from these barrels, we'll pump it into wherever we need to at that point in time. One of my favorite parts about this system is cleaning is so easy. All these glass lines and all the glass tubing and everything associated with it is all cleaned by steam. So we just send pressurized steam through everything. Some of the steam goes into the bags, but that's kind of okay. When a bag crashes, you take the bag down, and then there's a new bag, roll of bags on the wall, and you rinse and repeat. So super easy, super simple. And the labor on it, besides setting up initially, is pretty light. Generally, I would say maybe a week once the system is up. It requires maybe 6 to 8 hours of maintenance a week. So it's great for us. So, you don't have to replace them as much, very low contamination rates because of how the system is designed. A lot of the system, unfortunately, is glass, and glass, has a tendency to break no matter how careful you are. There's a colleague of mine, I know they got pretty hurt just from some glass tubing. So you always got to be careful when doing everything. And also kind of go into the real high tech of everything. And if anybody's ever interested in seeing these things firsthand, I'll type my email out when I'm all done, or you can chat with Kim. You guys are always more than welcome to come view everything. Just arrange it beforehand, just because we need to regulate the traffic going in and out of the hatchery for sterility purposes, but we're more than happy to have you and show you around. So these are kind of the latest and greatest in algae grown technology. So this does pretty much our job for us, in which all of the controls for growing other algae species are all controlled by this computer system, and I can control it through my phone too, which is kind of amazing. But they do a really, really good job of growing algae. And as I mentioned before, we measure everything in terms of density. So I can get algae in here 5 to 8 times as dense as I can in my CCAP system. And that's because of a couple of different things. One, the bioreactors create a perfect environment to grow an algae, and all pH, nutrient addition, water addition, everything's automatically controlled for how we set it. So it creates a perfect environment. But in addition to that, our biggest limitation is actually light. So the nice thing is these bioreactors have these cones that allow the light from the LEDs to pass all the way to the center of the culture. So your culture isn't light limited, which is really, really nice. So you have to imagine, right? We just have fluorescent bulbs on the back of these bags. And when they're not dense, right, light's passing all the way through. But when you get to kind of this point, and even to this point, light's not passing all the way through. It's only going to maybe a quarter way of the culture. So you get, you'll max out at a cell density. And the reason why we want to count and measure cell density is how we feed everything. So, you don't want to overfeed your babies because that could lead to a whole variety of different problems. So if you know how dense your algae culture is, you can calculate how much to feed based off that calculation. But two really cool videos I wanted to show you. Again, cleaning is also my favorite thing because in hatchery work, it feels like all you're doing is cleaning. And as you guys grow your oysters, I'm sure you're going to feel the same way, which is awesome. The cleaner you keep everything, the better everything is going to grow. But if you can cut down on scrubbing, it's definitely really advantageous, to me. So I got two videos to show you of this there's an automatic cleaning cycle that kind of works as a washing machine. So pretty much put your chemicals in. There's these little spray manifolds that spray out like a washing machine, and no scrubbing required. So it moves around and around. And this video I thought looked really, I think trippy is the best word to use. This kind of a view of the cleaning cycle from underneath. I thought this looked really cool.
Hey, Josh, I put my jeans in there last week. Are they done yet?
they may or may not have bleached out a little bit, but don't worry. They'll still look great on you.
Hey, Josh, I have a quick question.
Yeah.
You talk about your algae count, the density.
Yeah.
Okay, so this question was really before you started talking. It was about when Kim was talking, but how do you count that algae, that density? I know this R2D2 machine must do it, but how do you do it manually?
Yeah, so it's kind of funny. So the R2D2 machine actually doesn't count the algae cells for us. So this number right here, that you see when we see density, it's a meaningless number because all it is just telling me is my culture growing or is it dying. How we actually measure how much algae cells. So the algae strains that we grow, they're called microalgae. So microalgae are all microscopic individual cells. So you have individuals within this culture. So you take a small sample out of there. If anybody is familiar with a slide called a hemocytometer, it's a slide that are used to count blood cells. So you place a very, very small drop on the hemocytometer, and the hemocytometer has grids on it. And you pretty much count the amount of algae cells within that grid. And then from there, you can do a more, a calculation off of that to determine how many cells you have per milliliters of water. If anyone wants to see that in person, I can absolutely run through that in the hatchery. If I was in the hatchery right now, I could actually do it right now. But that could be for future. If anybody's, really further interested in doing that, we can for sure do kind of a live view of that in person if anybody wants to do that. Or we could do it over Zoom if there's enough interest and people, don't feel comfortable going, which is totally understandable too. Does that answer everything?
Yes, thank you.
All right, right on. So yeah, so cleaning is great, but there's also other, ways of feeding your shellfish babies. So you can have also just called algae paste. So it's just pretty much centrifuge or, press down concentrated algae cells. So instead of, having your real fruit juice, you're having your fruit juice from concentrate. Up here in New York and in the northern states, it generally doesn't really grow shellfish that well. We've used it in the past to supplement when our animals were eating us out of house and home. I know shellfish hatcheries in the South. I'm pretty friendly with a couple of shellfish hatchery managers in Alabama and in Florida, and they use exclusively paste and they don't culture algae themselves. So it's kind of really, really interesting to see the growing methods between North and South and just what all the other different hatcheries do. So again, to kind of bring everything going on to home, we're growing all this algae, and of course, all of it's being used to feed our shellfish. So right now, this was taken today. We are conditioning a batch of oysters for a February spawn. So the algae that flows into the barrels from either the bioreactors, and harvesting can either be continuous out of the bioreactor, or we can harvest it from a pump, which is this pump down here. But continuous kind of seems to be the way to go. It's just a lot easier. We get a lot more algae out of it. And so the algae will go into these barrels that hang above the tank. We drip a little bit of algae in over time throughout a 24-hour time period. The animals will eat it and eventually hopefully condition and look like that. And if we have a nice growth edge like that, then we know we did a great job feeding our oysters and they are happy and they are ready to spawn. So I am going to exit screen share now. That I think that's it.
Just a couple of questions, Josh.
Yeah, of course.
There was a question about rootstock and being indigenous or not. Are there any concerned about non-indigenous strains getting into our ecosystems?
So as Kim mentioned before, and I think I may or may not have mentioned it, and if I didn't, so the algae strains besides like maybe one of the Catastrophe strains we grow are not indigenous to us. But again, it would be a blessing if the algae strains that we grow in the hatchery take to our natural waters because of how delicious it is. You know, if one drop of unfiltered bay water got into my bags or even into my bioreactors, the algae would crash within 24 hours because it would get eaten by everything. And it's kind of biologically, it's incredible because you get to see the different, you know, protozoan life that can be found that eat all your algae cells. But like I said before, it's so delicious, it's not even a concern. It probably would be a great you know, a great thing for the algae to take and hold. You know, a lot of the algae strains, 2 algae strains that we grow are actually isolated from the Bahamas. So, you know, wintertime would kill it anyways. But it's really not a concern environmentally.
I think that's the issue too, is that if they could actually bloom up and establish themselves, we would probably have an issue with the DEC with our strains. Yeah. And the fact that we're allowed to grow algae and there's no kind of sterilization if you're pouring it down the drain or anything, just goes to show you what Josh is saying is we'd kind of love it if you know, some of these strains were blooming in our creek because our shellfish would grow really well. And they just don't have the ability to sustain our winter, so that there's no way that they're going to establish. But I think that if they could, we'd have some issues because you would have certain elements of ecology saying, well, you're introducing a non-indigenous species, and that's going to outcompete our local stuff, and that would be true. It's just not an issue. It's hard enough to grow this stuff in a laboratory situation, let alone having it take off outside. So,
and if anybody's really worried, you know, we can even sacrifice a carboy or do a test and put raw bay water into a carboy of bloomed algae, and you'll see, you know, pretty quickly how, you know, how fast that culture crashes or gets eaten. It's pretty incredible, actually.
Well, thanks, Josh. That was awesome. Those are great pictures, and it's an amazing facility. And, you know, that whole facility was designed basically with one thing in mind up front, which was algae. And it's got it because like you said before, without, you know, that's the nuts and bolts of growing everything. Everything is based on algae. So if your algae system is strong and your algae is good, then you've got the makings of what it takes to grow shellfish.
Most hatcheries' Achilles tendon is algae production, and that usually limits what a lot of hatcheries can do. So, you know, when you bloom it up, the stuff is worth its weight in gold in terms of shellfish production. You know, as you know, everyone grown in the creek, you don't necessarily have to worry about, you know, the hatchery microalgae strains, just because there's so much delicious algae, you know, naturally found in our water. And if there's something that, you know, our shellfish don't necessarily like, it's totally cool, because if they miss breakfast and lunch and still get dinner, that's fine. And the natural community changes over pretty much roughly every 3 days. So if there's something that, you know, they don't like, you know, 3 days later, there could be something delicious there for them to take and them to eat.
Awesome. Any other questions for, well, it turns out that Charlie and Frank got locked inside of the park. They just called me that they locked they locked the gate going out the park. We set them free. I gave them the combination. So
I'm surprised they're still locking it now.
So they've already, well, there were some issues about people driving on the beach. So Anyway,
that's
so
fine.
you can't ask questions of them, and Steve Schott's gone. So there's just Josh and myself and Darcy and the puppy dog. If you have any other questions, otherwise we can, we can, you know, I think this forum works really well to kind of open it up, and there was some alluding to what's going on for next month, which is we're conditioning shellfish to spawn, and we have our classic first spawn on Valentine's Day if we can do that. So you know, I think I'm tempted to record, you know, a live spawn or do a spawn on that day.
That would be awesome.
Yeah, I think, you know, I think the forum is good as long as the temperature goes above, you know, 15 degrees in February. I could get out of the house and get locked in at the park and, you know, spend the night in Josh's hatchery, which has heat. So
Just toasty.
no, but I appreciate everyone coming out. It was a tremendous turnout. It looks like we had about almost 40 people at its peak, and then everyone got hungry because all we talked about was eating microalgae. So we can all go out for sushi now. And there's and by the way, for new members or otherwise, folks. Oh, do I not have my here's my video on. Here's my video on. For folks that, you know, aren't familiar with our format, do go on our website and look at the last year's PowerPoints, because, you know, there's a huge amount of information on part 1 and 2 of algae. And we can, you know, the difference between our program and a lot of programs in this country is that, you know, I don't want to say we're on 24/7 call, because sometimes, you know, I'm definitely fielding calls. My first text was at 6:30 this morning. Can I come and get oysters through the ice? You know, and I responded 2 minutes later. We're around year round for questions. The Marine Center's open for SPAT Monday, Wednesday, Friday, 8 to noon still. There's lots of opportunities. I like these virtual venues in a weird way. I want to go live again, but, you know, it gives us an opportunity to all network in different locations, which is pretty awesome. And so, you know, if there's a hankering for addendums like more on the bioreactors or more on kelp, more on protocol, we can work up little snippets or whatnot. There's a lot of information out there available online. It's more fun. It's more gooder to do it with friends and folks we know. So I like it, and I'm glad everyone came out. And we've got a great team. I appreciate Josh there helping us out and everybody that was involved. So without further ado, I guess it's dinner time.
See you guys.
Hi, everybody.
Thanks, everyone.
Yeah.
Good job.
Thank
Stay warm.
you.
Thank you.
So I'm going to stop
Thanks,
recording.
guys.
I'm going to stop